Hello friends, welcome back. In previous class, we have studied regarding our threaded joint. In today's class, we'll learn about the welded joint and how does it works. Actually, this is a complete module of threaded joints and welded joints. Then after in this week only we'll have tutorials for your shafts as well as other parts also, shafts, keys, how it works. I mean the how it works and everything. That what I have to taught in your class, I will be teaching over here itself. Now, to take in a preface or in a way to understand it, you may take it in this consideration. So as we know that, let me change it. This is a welded joint. What do you mean by welded joint or welding? Okay, welding, this is nothing but a joining of two materials, especially metal or elastometal, or it may be non-metal also, because nowadays we have the facility to do that, but the non-metal needs a specified welding technique like laser welding techniques or something. So there it comes a combination of brazing and welding. So welding is a process of joining two material. So what happens is we provide a heat till recrystallization process, or it is nearby, it is about to melt. We take the temperature to about to melting process or about to melting. So that what happens, the melted material joins with one another melted material. So this is one part. We have provide heat over here, and also we provide a heat over here. What happens, these two gets joined because there is a melted thing. So what happens, two melted bodies get attached. Same like this, as it's termed as T joint, it's termed as corner joint, it's termed as A joints, it is termed as butt joint, and it is termed as lap joint. So what happens that a material surface gets puffed up. It's something like your soldering of two wires. What happens if we solder two wires? We could see extra material is over here, that a shiny material is over there. The same thing happens over in welding also. So what happens is, if two materials are joined by application of heat, there is a small heat, material over there which has to be which is the extra material or filler material, which act as a binding material to bind in between these two. Now this point comes that if this is a filler material, what is the tubular filler material? Filler material is a binding product, or it's a binding agent which helps to bind these two. Now filler material itself doesn't work, it needs something to initiate. So we use other metal or alloy similar to plastic ranges of this one. So what happens is there's an electrode, as you can see, there's an electrode which is a specialized electrode, which is a complete rod. You may take it in this manner. Let me draw in a screen, a white screen. This is my pen. Okay, this is a rod. What happens is, if you consider this is a rod, this is a metallic rod which will have a similar material property or same material property, that depends on the type of welding you are doing, what welding you are doing. There are several types of welding. There are near about 200 plus types of welding. So as the welding what you see over here in Bengali, it says jhalai. So you know, everyone, we know that the words. So in Hindi it is a take lagana. So this is what happened. So what happens is we try to join two materials. So two material properties should be exhibited over here. That means there should the three materials, that is the rod, the electrode, the two base material, which materials will be joined. All three of them should have similar material properties. Now it will not join when it is given, when it will be when welding process will work. But so that what we do, we keep one more we give one more thing, coating over here over the material property. This is termed as the filler material. What this does, it acts as a binding material, binding properties, or it generates the heat properties or replicates the heat properties, as well as it shields the oxidizing properties to a limit for which this melting process can be done. So how it works, this is connected to a power station. Okay, there is one more table. This is a table. Which one? This is also connected to a, so there is one polarity that depends on the polarity. What happens in the polarity, we actually the polarity can be reversed, or polarity can be, so what happens, the in majority of it, what we consider as a plus and this is a minus. So this can also be altered. So this is not that you have to keep it plus or minus, because we could alter it. It could be AC current or it could be DC current. Here what happens, the maximum in the welding process, it is done with a formulation called Q is equals to I square RT. Remember, I'll ask the formulation of welding. I'll ask you in your exam, what is the formula which makes heat of this? So this is the I, this is the heat, this is the R is the resistance, and T is the temperature. T is the ambient temperature. Okay, R is the resistance between this and this. So what happens, and I R resistance, and I is the current passing from this region to hold this one. So what happens, it comes in contact with this one. So you keep a material over here, and let me erase something. What is the eraser? This is the eraser. Okay, where is my pen? Ink color, let me change the ink color blue. So there is a material over here. Let us consider a material. So what happened is, this two material 1 and this material 2. So what we do, we bring this electrode over here and we run over here. So what happened, there is a conductivity, electrical conductivity over here. This is a metallic table. This will be a metallic table. What happens, there's a transfer of material or polarization. What happens, due to the electron polarization of these things, there's a heat transfer over here. What happens, if the heat transfer, the temperature of the material rises, as well the temperature of this metal also rises to the melting point. It's near about 95% of the melting point. Why 95% of the melting? Why not 100%? If it's 100% melted, it will destroy the complete material. So maximum we could go for 95% of material melting point. So there is some recommendations by welding societies of entire world. So we have to take in this considerations of them these things also. So this is what welding process works. So this is the governing formula of welding process. This Q is equals to I square RT. Q is the heat, I is your current passing from this, and R is the resistance. Is the contact resistance from this point to this point. So this is not the resistance which is you are getting from this. Is a contact resistance from this electrode point to the material contact point. So it is calibrated in the way of by using some oscilloscope and everything. So here comes a mechanical related to electronics or electrical things. So let us go back to the our screen. Okay. So as you have learned over there, that means this pudding or this is created due to this material, extra material, what is impounded on while welding. That's what you can see over here. This is over here. This thing. So these things are also named as fillet or chamfer. Okay, this is actually named as fillet. Okay, chamfer is not like this. This is named as fillet. Okay, now let's go for the next thing. How to calculate the strength of this butt joint? That means the extra material what you are providing over here. How to calculate it? So scientists came up with the simplest idea. Simplest tool. Let us consider the tensile force, tensile testing way. So this is a material 1. this is a material 2. This has been joined by a by welding process. This is the welding material or the welding metal, as well as some filler materials that feel somewhat, because filler material gets evaporated when the welding is completed. It because of the heat, enormous heat created. So let us take the cross section of this one. The cross section is H and the length is L. So what will be the cross sectional area? H into L. So what will be stress? We know stress is equals to force by area. So we know the stress is force by area. So let us go. Sigma is equals to force by area. So what is the force acting over here? Force is this one, and what is the area? This multiplied with this. So H into L. Fine. So what will be P? P is the force. What is the recommended P for this? P will be sigma T into H into L. Sigma T is the maximum tensile stress, or if we consider in an industrial way, the maximum force what I can apply is the maximum allowable stress. The maximum allowable stress, let me change maximum allowable stress into T into L. What is T? T is nothing but T can be the H or thickness. T here T means the thickness. You could use T as a thickness. So it is not given over here. T can be written as T. H can be written as T also. So this is the same thing around. So T into L or H into L. Okay. So thickness of the plate or the thickness of the welding part. So after that, what we can do is we have to find out does it works in this way? Will my this thing will work? So we find out a way out of it. We have a eta that is efficiency, that is called welding joint efficiency. Now how do we calculate the welding joint efficiency? Let me tell you in a simple word. So let us consider a material, a welding joint. There is a joint of a welding. So we are providing a force, we are applying a force P, and we are applying a force over P over here. So what happens, the applied force and the braking force, try to understand, the applied force and the braking force is compared, as well as in other way we should say the applied force and the actual applied force and the calculated theoretical force is equals to the eta. So what happens, eta can be calculated in this manner also, the P theoretical by P actual. So this actually depends on what criteria you are working, there are so many criteria of welding, so it depends on this. So this is what we can get. Next, what is the strength of parallel fillets of the welding? So scientists came up with new ideas of how can you use it on the thing. This is the T joint. So this is a T joint. So what happens is there is force acting over here and force acting over here. So there is a shear stress generated over here. So as we know, the maximum stress or the maximum minimum stress acting on a body is on the 0 or to 90 degree. Fine, but in the middle there is a 45 degree also. Fine, the mid section is 45 degree also. What does it teach us? It teaches us, if you consider a 45 degree angle, you may be in the positive side. For example, let us consider a crack or a crack propagation from this point, the fillet, at an angle of 45. Fine. So what will happen if I consider this is the T thickness, that is the lateral distance from this point to this point. This is this point to this point, and H is the height. H is the distance from this to this or this to this. So what I can do, I could consider, since it's an angle, this is here to here, it is H. So I could bring the stress over here or over here. So what I can do, I could write the T cos 45 equals to, if it's like this, if you consider, let me erase all the erase all ink. So let me consider this is T, this is H, and this is 45. So what would be the angle, what would be my formulation to find out this to be in a single part? This is cos 40. So how much it will be? It will be T by H. T by H. So what will be T? T is T by H. Sorry. What will be T? T is equals to H cos 45. So why 45? Because 0. If we consider 0, cos 0, that means there will be no problem. There is nothing. The two are the maximum and minimum boundary condition. I will not consider the maximum minimum boundary condition in terms of welding, because this is a material pudding. If there is a material pudding or material structure, extra material structure, what will happen? There may be certain cracks, because it has been also this complete thing has been recrystallized again, as well as it is keeping a connection with this point as well as this point. So what can happen if there is a crack or the grain cooling? So what happens if the grain cools and there is a stress, so small crack generation, this may break. So to find out the critical way, the critical angle where it can break, we consider 45 degree. So as well as it has been found that 45 majority of the cracks are obtaining in 45 degree. Now as we know, cos 45 is 0.707 H. So what do we do? Again, we will go back to this one. It is H, and this is this section H into T. So what? How much will be the thickness? So sorry, H into L. I am wrong. H into L or T into L. So in other way around, let me get it in the shortest way. We know tau is equals to shear is equals to force by area. What is force? Force F. Let me consider the force. Force is this one. What is the area? Area is the cross section where it is working. So this is the plate thickness T, fine, or the thickness. And what is plate thickness T? As you can see, the T, and at what distance it runs? It runs at L. So T into L. So T into L. So what is T? 0.07 into H into L. Fine. This is what it is. If it is done over, this thing is also done in this side also, as well it is done actually, this type of welding is done in both sides, then it will be 2. This is what the things, if both sides are welding are done. Okay, this is a lap joint. How to consider this angle? You may tell me that, sir, this is the value of cos 45, but here it is given 67.5. Now let me tell you, this is a experimentation value that showed that 67.55 you could maximum go to 67.5 degree. That means if you provide a stress over here, if you put a force over here, they are both at the end, this fillet can break at an angle of maximum 67.5 degree. This is practically done by ASME, that is the American Society of Mechanical Engineers, as well as the Welding Society. We have a Welding Society in West Bengal also. That is the name of the society is Indian Welding Society. So that we put the journal papers or the research papers of welding. So what happens, you could get from there also the same thing, same agenda it will tell you. So as you can see, this is the maximum angle, but we will consider at 45 only, because we will not exceed 45. 45 is maximum, but we have 67.5 that is calculated as well, that is calculated as well, that is experimental. So if you actually derive the how much angle clearance I have, that means 67.5 minus 45, it is never 22.5. So if you consider a material of, if you design a welding pudding or welding fillet to break at an angle of 45, then also you have a window of 22.5 degree. So that means you could, if it breaks with overstressing also, it will need more 22.5 degree. So this is what a factor which works. So this is completely on the other way around. So fine, this is what the thing, that is we will consider, we will calculate 45 for being in the safety zone. 67.5 is the maximum to maximum, so we will not go for the maximum. So we will be in the mini, we will be not into the actual, we will be not also in the minimum angle, we will be in the adequate angle. The adequate angle is 45. Now, so if you have parallel shift, so the thing is that the same thing, this one, if you have parallel, the thing is that if you have this thing over here, I told you could give two. This is, as you can see, this if you have two parallel things, so you need twice the force of this one. This is P, so you need to give it 2P, as you can see over here, 2P, and then this is fixed. This is not drawn over here, it is fixed. So what happens if it's given 2P? The thing is that everything gets changed, so the formulation remains the same only. There is no such changes. What we do is we find out P max on everything. So what we did is we consider a small point at an angle with the theta. So we have not considered the angle, the theta. Last of all you have considered 45 but at initially you have not considered, but initially we have considered 45. Okay, fine 45. So what happens is if it's a h, then h is equals to, we have calculated by using trigonometric formulations. So it gives me tau is equals to P sin theta plus cos theta. That means we are considering stress in both sides, even this side, even this side. Fine. So what happens, you get P sin theta plus cos theta. Then after P sin, as well as we integrate it and at certain angle to find out the maximum and minimum angle. So we found that the minimum or maximum angle is 45 only. That's why we consider everything in 45. So after that, after seeing that it's coming in the 45 angle, so we put this thing again 45, and we get the same formula. That is, we'll be backing to this formula. So this is the elaborate part of the things. Okay, maximum shear. So finding on in a transverse or in a transverse way. So if you fix this one. Now if you try to understand this, because derivations, what you can learn from, you can learn everything, but the thing is that to learn in the how it works, the mechanism is the main thing. So you fix this part, and you are forcing upward. What happens, there is a one force comes. Now what this thing is, you have learned in by Shubhrato sir has taught you in your previous classes, previous semester, that if a normal force is acting over here, then you will find two shear force acting. If a normal force is acting on a principal plane, you will find two shear stresses, or a normal stress is working on the same thing. So you may see in the other way, this is a shear force. Here is not shear stress, here is shear force. We are considering shear force working on it. So there is one Pn and what is Ps. So after that, what we do, we consider the equilibrium equations, like 2p, that is a 2p, and after the angle theta, and you can get 2p sin theta, 2p cos theta. As you can see that if you take it over here, that is, if it is an angle at theta. So what happens is Pn cos theta. There is Pn cos theta over here as well as here, therefore 2, and Pn sin theta, it is Pn sin theta, that is Pn sin theta, because it's an angle, and Ps cos theta is Ps cos theta because there is an angle of theta. So what happens is, if you take it's an angle, so it will go for the same. So Pn sin theta, because it will be cos in this way manner, and therefore it will be sin on this way. But in terms of Pn, what happens is Pn is having an angle in inner side. What happens if it's something like this? Pn is having angle in the inner side, so Pn is acting on this one. This will be cos, so it will be Pn is having angle in this way. Let me draw on the thing. This is having angle in this way. So so what happens is it working is over there. Let me show it actually. Pointer, eraser. Okay. As you can see, Pn is having an angle. So what is happening the Pn angle? As you can see this diagram, Pn is having an angle this way. So what is happening? If you consider Pn cos theta, the stress will come in this way. So this is what it's showing. So this is what deliberately we are trying to do. As well as you can see, the PS is working on a downward, so this will be the PS cos theta and this will be the PS sin theta. So PS sin theta and PN cos theta both are working and they are working downward. That's why here it is opposite to each other. So this gives the equilibrium equation. Then after we find out what is PN and PS relations. So substituting and the PN to over here, and this is the game of the substitution. Again we find the PS, again we substitute. Again, since we have studied from over here, T is equals to TH by sin theta, as we know, we have learned from this from here. So we could derive it. As you can know what is BD. BD is the T dash or the thickness of the thing, and H is the T dash, the thickness of this one, as you can see, the fillet thickness, and H is the length of this one. So we have calculated by trigonometrically. So after putting this entire over here, so what happens is we get we differentiate to be 0. To why 0? Because to find out the maximum and minimum, whether the angle is 45 or not, or what is the angle acting over there. So this give me a theta of this. After that I use the DUV relations on this, as we know. So what comes is x is equals to theta, u is equals to sin theta. So what we get is substituting everything, we get sin 2 theta, sin cos 2 theta. So after that, if you get 2 theta is equals to 135, that is theta 67.5. So there comes, as I have told you, this is a theoretical value as well as practically proved value. So you could find out that it was the for this is 0.7005, whereas this is, you can see, 1.114 HLHT, but the formulation gets changed over here. It comes at 0.825 tau max. Now this is a theoretical way as well as the practical way also. For practical way we find out near 65 point something angle, but 65 point something. So the way around and in the other way around, this remains the same. So what I can understand is the complete from the complete theory of this thing is that to find out a thing, maximum fillet, maximum shear stress, we could take this one, because it's a practically as well as theoretically verified. Because theta 67.5 can be derived theoretically, and in practically we can find 65 point some degree. So 65.6. So this is the preferred way to preferred formulation to do. But in terms of mathematics to learn, in terms of learning, we could actually take this one. So let us go, start with one more thing. There are last two topics. One is asymmetrically loaded, and this is two asymmetrically loaded, and this is a bending loaded. So I have this is a mistake over here. So this will be bending. This will be bending. Okay. So let us understand in short. Let us consider a plate is welded over here. It's plate. Let me take my laser pen. It is welded over here and it is welded over here. So a force is acting over here. If we are applying a force, and the center of gravity is assumed to be over here. So what we assume is we are assuming that the complete effect, moment effect, is acting on this G. What is the G? G is the gravity, center of the gravity. So what happens? There's a moment over here, as you can see, the moment as well as the moment. So we are considering a moment to be acting on the center of gravity. But it's something like this is something like assumption, but because we have to consider, there is no other way around to this, because this is the major drawback of everything, because we are considering everything in terms of a center of gravity. But sometimes center of gravity gets shifted, or center of gravity is something it's not constant. So but as terms we are related to theoretical, then we can go for practical. So we have to consider for theoretical purpose, we have to go for the center of gravity to be fixed on this one. As you can see, this after considering these two points, these two diagram, what we can see, the tau 1, this is the maximum stress, is equal to force by area. We know that. So what happens if we consider this is a plate, as you can consider a plate where a weldment, or this part is called welded or weldment is done. So we can see the force is acting actually. So we have shifted the complete entire effect, momentum effect over here. So we can see the force is acting over here. So a force is acting over here, and a reactive force is acting over there. So as you can see, the upward force active reaction. So what happens? There is a shear over there. That means it will break off. It will shear off as well as it could shear off. So let me bring my pen again. So you could see this will shear off, as well as this is a tendency to shear off, and this has also tendency to shear off, and this is also tendency to shear off. That is, the shearing off is also at the at your it's your anti-clockwise, because the bending is in the clockwise, as we know that. So what we can do is we could actually see, we could take it in this way, that tau 2 or tau 2 due to tau 2 of this one, tau 1 was for tau 2, or you can see the bending stress, the shearing stress due to bended is, we can set mr by j. That is denoted, or that is calculated from the torsion sub chapter, where you have find out that tau by r is equals to m by j, or it was something like tau by m is equals to r by j. So m is the moment, and j is the polar moment of the entire body. So let us consider this to be a rectangle, the cross section to be rectangle of thickness t and length L, and this is the x-axis and this is the y-axis. Let me bring this one, my pointer. This is considered as a t. The pointer this is the center of the gravity. Consider this is the length of the body is L, and this is y-axis considered, and the axis considering center of gravity to be at the origin 0.0, and the radius and the height is elevated is r1 from the center of gravity dot g. So the dot g, this is the center of gravity, it's bit above the g1. So we have considered this is y, because this is the weldment, this is this part, this g, okay, and this g is this part. There is the center of gravity, g1 is the center of gravity for the weldment on the welded area, and g is the small part of the center. Fine. So as per the x-axis, I can find out the moment of inertia, since I have to find out j, that is a polar moment, the entire polar. So what I can do is I-axis, in terms of x-axis, this is it cube by 12, that is bd cube by 12, since it's a rectangle structure. As well as iy, this will be bd cube by 12, as I know. So adding up these two things, we can get the we could consider that it's in a y direction, in the big Y. Why it is in a y? It is now and then in the y direction, as you can see, because the length is maximum considered to thickness. So that's why we'll give more preference to the length rather than the thickness. So what happens is this point thickness is also not so much big, so to be considered. So it's very less we consider, but actually that makes an effect in practical life or practical weldment things. But in theoretical, it's very okay to take. Fine. The theory is other thing and the practical is the other thing. So those who want to learn about the practical or industrial factors, how it works, I give you in a small steps understanding. If you wish to just knock me over door, fine. So what happens is JG, I know that this one, I'll put this thing over here, and I know T into L, the cross section, T into L, this is area, and L square, as we know. So GG is JG1, that is for polar moment of this area, will be AL2 by 3. So for this compared to this area, it will be R1 square, as we know that. So we know that this gives us the JG, and how to find the moment, as we know that the moment can be, how to find the moment, as we know, the moment could to be calculated in the way with the M is there. What is the moment? P into E. Fine. And R. So what will be the moment? This I have not given in your notes because I have kept it is you as your assignment. So but this will be very good to tell you, or rather you can say that it will help you to find out, to find out the way how it is done. So in books also you will find out it has been done till this 7, but I'll not do this one. I'll complete it over here. So as you can see, pen, let me take sigma or tau is equals to moment, you know, is P into E, okay, into R by this entire thing. Fine. Now try to understand A. How much is A? A is we know A is T into L. So what comes it in this way? If I see P E R by T L into the entire inside. This is what happening. Fine. The same goes for bending also. The same category, same thing is used for bending. Now, what do you know? We generally know that tau is equals to P by A, but there is a force acting which is creating a bend action over here. This is, can anyone tell me what is this one? This is a cantilever beam. As we know, the cantilever beam is one end fixed, one end free. So what happened is, if your force is acting over here, so there is a bending action on the on this force. So what happened is, again we consider the same thing. We take it in the center of gravity theoretically, but it's not practically, guys. Please remember, it's not practically. So tau is equals to, what will be tau? Total tau is equals to sigma b by square by 2 plus tau 1 whole square. So what is T? Now you could say that there is a shear. The complete shear is equals to the shear of this this point, as well as the bending action. Bending action is divided by 2 because it's a symmetric. So we consider the half. If we can, now there was a problem. Why do I considering the half? Because if it is safe in the half portion of the body, that means it will be safe on the other half. So we design for the half and we multiply with 2. This makes our calculation more easier. So for in terms of bending, so what to do is, we know bending is sigma b by y by I. We have calculated the b or I, that is earlier we have considered this as b and this is the d. So what is a rectangular as b and t? So b and this thickness, this here to here. Let me delete it, the entire screen. Okay, it is all ink. So this b is this b is from this length, okay, and t is the thickness from here to here. So bt cube by 12, that comes near about what you get. So Ix is equals to bt by d square by 4. After putting this entire, we know this is twice. So what do we do? Twice 2 into Ix. So what, since it's a symmetric, what we do? We put over here. This is what we do. This is what this comes. This is a bending. Okay, this is what your welding chapter is there. So this was the part of the bending moment and the bending on the node. So the rectified node, by changing this name, I'll be giving you by today. I'll give you today itself. So check your Google Classroom and try to and please subscribe to the channel to get the videos, because you have to get the videos for your exams, because the question will be from the videos as well as from my notes itself, from basics, some basics also. So get your queries as soon as possible. Thank you. Be at home, be safe, be at home, stay at home, don't go out of the place, and be safe. Thank you.